we're going to talk about factoring the difference between two squares. And we use the difference of squares when we're given only two terms. It's important to note that you can only use DOS, difference of squares, when you have two perfect squares. Something else that we didn't write down on here that we should have written down is that we should always watch out and see if we have a greatest common factor in these problems. But we'll deal with that when we get there. Let's take a look at a little bit of a review here of the distributive property. Sometimes you call this FOIL. And FOIL stands for first, for F, O, outer, I, inner, L, last. When we multiply, we really distribute the x over the x minus 6. And then we distribute the 6 over the x minus 6. So when we do that, x times x is x squared. X times 6, in fact it's x times negative 6, is minus 6x. Then we do plus 6 times x, the inner terms, and finally 6 times negative 6 is negative 36. Once we take a look at that, what we see is we have a negative 6x and a positive 6x, and those two terms cancel out. So we're left with x squared minus 36. On example B, it's the same kind of thing. We take 2x times 2x, which is 4x squared. 2x times negative 5 is minus 10x. 5 times 2x is plus 10x. And positive 5 times negative 5 is negative 25. When we look at this again, what happens is negative 10x and positive 10x cancel out, and we're left with 4x squared minus 25. So, what patterns do we observe from what we see here? I wrote down a few. There's more than probably what I just wrote down. But some things that I observed. The outer and the inner terms canceled out. Negative 6x and positive 6x. Negative 10x and positive 10x. They canceled out. The first term and the last term are perfect squares. X squared is x times x. 36 is 6 times 6. 4x squared is 2x times 2x. 25 is 5 times 5. Again, these aren't all of them. These are just a few that I came up with. Notice that when we finished, we had a minus sign in between both terms. And then I wrote one more. We ended up with just two terms. X squared is a term and 36 is a term. 4x squared is a term and 25 is a term. So there are some patterns. Again, you could probably come up with a couple more. Well, I've talked about it and kind of even explained it, but what is a square? Well, a square is a number times itself. So 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, which is 36. 7 squared is 7 times 7, which is 49. 8 squared is 8 times 8, which is 64. 9 squared is 9 times 9, which is 81. 10 squared is 10 times 10, which is 100. 11 squared is 11 times 11, which is 121. 12 squared is 12 times 12, which is 144. 13 squared is 13 times 13, which is 169. 14 squared is 14 times 14, which is 196. And 15 squared is 15 times 15, which is 225. And some of those you probably remember from our quick recalls earlier in the year. Does it make a difference whether the number is positive or negative that we're squaring? No, because negative 2 times negative 2 is still positive 4, or negative 7 times negative 7 is still positive 49, or negative 12 times negative 12 is still positive 144. So no, it does not make a difference. But how does factoring a difference of squares work? Well, there's a pattern. We break it up into 2 parentheses. And x squared is x times x. B squared is b times b. And it's called the difference of squares. Well, if you know the definition of difference, difference means it's an answer to a subtraction problem. One sign has to be negative, one sign has to be positive. It doesn't matter whether you put the minus in the first parentheses and a plus in the second parentheses. I tend to put the minus first. X squared plus b squared? Well, there's a plus in here. There is no subtraction, and difference means subtraction. So this one is prime. And we saw a prime on one of our worksheets we did last week. So to finish, let's practice some. Notice there in the directions, don't forget to factor out a greatest common factor first, if we can. And as we look at this first example here, we cannot factor out a greatest common factor. So what we're looking for is, how are we going to break m squared apart? Well, m squared is m times n. And by the way, we want the same factors. 16 is 4 times 4. And n squared is n times n. Difference between two squares, different signs. Again, I tend to put my minus first and my plus second. It does not make a difference. But one of the parentheses has to have a minus and one of them has to have a plus. When you look at these problems, you always want to look and make sure that there's a subtraction problem. Because if there's an addition problem, we cannot factor the problem. We did start off with a binomial, 2 terms. Binomial, 2 terms, bicycle, 2 wheels. 4a squared is 1 term, 9b squared is the second term. If we look at 4, we saw that on our front of our notes there. 4 is 2 times 2. A squared is a times a. 9, again, if you need to look on the front of your paper, 9 is 3 times 3. And b squared is b times b. Difference between two squares, different signs. There's a definite pattern to these. Now, sometimes people look at number 3 and they go, oh, I can't do this one because it's got a fraction in it. But is it subtracted? Yes. There's 2 terms. Good. X squared is x times x. So the only question remains then is, how are we going to break 16 or 1/16 apart? Well, 16 is 4 times 4. And that's in the bottom of the fraction. So I wrote it in the bottom. 1 is 1 times 1. Difference between two squares. By the way, you could type in the square root of 1/16 because squaring and square root are inverse operations. And that would be another way for you to come up with that 1/4. When we look at these problems, we should always be looking for greatest common factor. And as we look at this problem number 4, hopefully somebody sees that there is a greatest common factor in it. And the greatest common factor happens to be a 3. So we're going to factor that out. 12 divided by 3 is 4. 4x squared. 27 divided by 3 is 9, y squared. We have a binomial with two terms, and hopefully we have a minus sign in between, and we do. And because we do, we can break this binomial up into two more binomials when we break apart 4 into 2 times 2. Same values. X squared. X times x. 9. 3 times 3. Y squared. Y times y. Difference between two squares. Different signs. And we finished our problem. We factored it completely. Again, when we look at this, we need to watch out. Do we have an overall GCF? And we have an overall GCF. It's 3. 3x to the 4th divided by 3 is x to the 4th. 75 divided by 3 is 25. Is this problem a subtraction problem? Yes. That means that we can factor it some more. And remember, when we factor, we want to have the same factors in each parentheses, just with different signs. So how are we going to break x to the 4th up? Well, we're going to break it up into x squared times x squared. And 25 is going to be 5 times 5. Difference between two squares, different signs. Make one of the parentheses with a minus, make the other parenthesis with a plus. To finish, it looks a little bit different here, but we can still factor this problem. It's a binomial, and there's a minus in it. It's written non-traditionally here, but there's nothing saying that we cannot rewrite it as a to the 4th minus 81. I didn't change any signs on a to the 4th. The sign in front of a to the 4th in that lavender color is still positive. The sign in front of the 81 is still a negative. We didn't change anything in there. We have a binomial with a minus sign, which means that we can factor it. We want to break it up so that we've got the same factors in each. And when we do, a to the 4th is a squared times a squared. 81 is 9 times 9. The difference between two squares, different signs. So all of the rest of the problems we finished at this point, but we need to take a close hard look at this one because we did break it up into two binomials, and one of them still has a minus sign in it. And in fact, what happens is a squared plus 9, that has a plus in it. We cannot do anything else to that problem. We would call it prime if it stood alone. But a squared minus 9, we can break apart into terms that have the same factors. A times a is a squared. 9 is 3 times 3. The difference between two squares, different signs. For the remainder of the period, I need you to work on problems 1 through 9. We will review tomorrow before we take our quiz over difference between two squares tomorrow, Tuesday.